This technical short video is brought to you by Dave Kameen, VP of Marketing for JPS Interoperability Solutions.
Let's talk about the RSP-Z2 interoperability basic configurations. Now we're going to talk about the Z2 independent pass-through and the local settings choices. On the left-hand side, you'll see the channel 1, local, several designations or several protocols that you can choose, or radio or headset that you can pick to be the input for the local channel 1 side. At the top we see RoIP, that's the JPS RoIP. Down below that is RTP, real-time transfer protocol. Below that is a radio. The radio will connect to the DB15 connector on the back. Below that is SIP, and below that is the USB headset when plugged into the USB port. By selecting RoIP on channel 1, the radio DB15 connector in the back is not used. The IP configuration is completed in the setup screen, and when you select RoIP, SIP, or RTP on the local side, you are setting the Z2 to convert protocols. You won't be using the DB15 for the radio connector. When we go to the backhaul side, we have the similar choices. There's bridge, RoIP, RTP, SIP, and VIA. The bridging channel will be discussed later. It's the capability that provides 60 to 80 channels in a wide area network with Z1s and Z2s. So the choices are bridge, RoIP, RTP, SIP, or JPS VIA. JPS VIA would be using the JPS RoIP to go to the VIA server, which would go connect to the VIA users on their cell phones. So by selecting RTP on channel 1, which is the backhaul side, the incoming signal, in this case we choose RoIP on local 1, is converted to the outgoing choice on the backhaul side. We chose RTP. The IP configuration is completed in the setup screen. By selecting RoIP on the local side and RTP on the backhaul side, you are setting the Z2 to convert protocols. A simple block diagram or a simple pictorial you see now, and that shows that we have RoIP coming in local 1 input, and we have RTP going out the channel 1 backhaul. If we talk about channel 2, the settings are similar or the same. The channel 2 on the local side gives you the choices of RoIP, RTP, radio, SIP, or the USB headset. And on the backhaul side, it's the same as the backhaul on channel 1. It's bridge, RoIP, RTP, SIP, and JPS VIA. A simple pictorial of the settings that we chose. We have radio coming in, that's through the DB15 connector on the back, and we have SIP going out. And that could possibly be going to a SIP PBX or a SIP phone or client. For the independent pass-through, here's a pictorial that shows what's happening. You have the red path and the green path. Those two are independent of each other. On the input side, you have radios or consoles or telephones or anything along that path. You also have the capability of bringing SIP, RTP, or JPS RoIP into the input side by using the IP connector. And on the output side, you have SIP, RTP, or JPS RoIP. And what you have here in the red and the green is really two individual streams. On the output side, you could have a web browser and the IP connector. You can have JPS gateways. You can have another Z2. You can have a SIP phone or a SIP PBX. You can have Cisco Call Manager or JPS via smartphones, or any assortment of equipment that uses SIP, RTP, or JPS RoIP. So in this mode, the Z2 acts as a pair of independent cable extenders. It transfers audio plus PTT and core signals via IP from local radio or PSTN sources to other devices. The unit behaves similarly to a 1 or 2 channel version of the popular JPS NXU2A or the ARA1. Many added features such as RTP are in the Z2, along with the JPS RoIP and SIP, and if desired, a PSTN interface. One of the two analog ports can be a PSTN interface. There's a single RJ45 Ethernet port and an IP address, but in the remote extension mode, each path is independent of the other. Transport protocol for each path, SIP, RTP, or JPS RoIP, is user configurable depending on system requirements. Here's a pictorial that shows the same thing as what we've been seeing. You have radio 1 on the right on the blue path going through the Z2 to be converted to SIP, and it's connected to a SIP PBX as an example, and all the extensions out there can call each other, or they can dial the extension of the SIP capability that goes back to the Z2 and connects to the radio. So just simply dialing 100, for example, on the SIP side could connect you to the radio. On the lower path, the red one, we have a radio 2 on the right. We're converting that to JPS RoIP. In this case, it goes to an NXU2A that has a radio. Of course, that JPS RoIP could go to any of our devices or any of our products that do JPS RoIP. It could connect to an ACUM. It could connect to an ACU 5000. It could connect to a 2000, etc. So on the right, we see the choices. Again, the local input, RoIP, RTP, radio, SIP, USB headset. In this case, we have the radio selected because we have a radio connected to the local radio 1. On the other side, we have a radio as well, so we've selected the radio. On the top side, on the left, we've got SIP, so we selected SIP. And on the lower half, we've selected RoIP because we're using JPS RoIP to go to the NXU2A. In reality, what we're doing with the independent pass-through is we have two totally independent paths. See radio 1 and SIP on the top, and radio 2 and JPS RoIP on the bottom.
This just came out. The RSP-Z2 from JPS Interoperability Solutions is the solution to your communication needs. This versatile VoIP to analog interface allows a radio, a pair of radios, or a radio and a PSTN connection to be patched together and or remotely interfaced to other devices or to a dispatch capability via various common protocols, SIP, RTP, or JPS RoIP.